And so where we left off at the quad tree. Some things I've been working on offline is just getting our test coverage up. So here I've been kind of extracting things out of the game server. We got more tests here, and then you can actually see where our test coverage lies. It's still not even anywhere close to where I want to be, so I'm just been working on that offline just to kind of get that up. All the functionality is still there, just making the things a lot more stable. I need that to be running. So I guess not stable is not really the correct word. It's more just tighter, making sure that we're covering our code. So let's get back to our quad tree. What we need to do is we need to have it split into more trees if we hit a threshold of our count to split. So what we can do is we need just an interface to quantify the differences. Maybe. Let's see, let me think about this. So I haven't been able to think much about this since the last time we were here. So in fact, I need to make sure tests are still passing. So what we need to do is when we get to a certain size, we're going to need to split it and then recursively refill it. So let's hop to it. So what we need to do is we need to find a way to see what we got here. I feel like we need to do like quad tree leaf. And there we go. And then create a interface, which is a quad tree node. Okay, I'm going to keep that empty for now. And we're going to replace all those with quad tree node. Okay. And then this will implement a quad tree node. And this will implement a quad tree node. Okay, so that we're working with the same types here. Now, here we're going to say split into 4 trees if we hit a threshold. What we're going to need to do is we're going to need to have a way to validate that. Var. Actually, you know what? We have the public tree, so what we can do is validate that our tree, which is an array of quad tree node, quad tree tree. Okay, and so now we can say assert is true that tree index 0 is a quad tree. And that should do it. In fact, we could make this a little bit more tightened up so that we see that here. It's probably excessive, but we also need to know the public area, total area. Okay, so what we can do is our tree node quad tree equals. So that's one thing we can do to our quad tree node, is we can have our area. And this is just going to be a getter. Okay, so now we say get null, and we'll do a getter area public, and I should do that. And we're going to have to rename this to area. And we need to set up a getter for it. Getter area. And that should has no field data. So here we're going to need to do line 23. This is going to be quad tree node leaf. And 961. So there's no way to really know. So we could cast this for now as a quad tree node leaf. And I'll get that to build. And then line 82. Item. And some of these probably probably aren't necessary. So some of these functions are kind of excessive too, but we have them, so I'll stick with them. This one here is not quite complete. And this one here is not complete. And quad tree 155. Okay, we have a quad tree. Okay, so this is going to be a quad tree node tree and assert it's true. I'm sorry. This is going to be just use quad tree node, yeah. And now we can assert our equal that it's going to be this in half. So this will be 400. Oops. 400. This is going to be tree node area width. And this is going to be 600, so this will be 300. This will be height. And then for this one, the x and y won't change. So x will be, let's see here, x will be 50, and this will be 80, x and y. In fact, I'm going to move these up here. And so we're going to need to do that for each of these. And so f validate quad tree. So we're going to need the tree tree node, and the I'm going to need the dimensions, so x, int, y, int, width, int, height, int. Adds. Okay, so here we're going to blast that there. We need to do this here, and we have our tree, so we can just take this out. We call this tree node. Tree node. Okay. Now we don't even need this. Oops, we didn't. Is type. There we go. Actually, I think it's in here. What does it say? Value. Okay, so. And then tree node. Should have it. Is that the wrong tree node? Tree node, tree node, tree node. Oh, what is the button here? Oh, it's a quad tree node, that's why. Quad tree node, okay. So now we can say validate quad tree, tree 0, 50, 80, 400, 300. Alright, that'll dry that up. X, Y, width, height. There we go. So now I'm going to validate more of the tree. So 4. So 1, 2, 3. So the next one is going to be the rectangle to the right. So that's going to start with 450, and the width is going to be the same. It's going to be the quadrant below the first quadrant, so it would actually be technically 3 if you look at it mathematically, and that the y will start at 380 because it's 300 plus this, and then 450, 380. Okay, so we should have a ton of failures. And there we go. One major failure. It's not a quad tree. Let's see here. 9161 is not a quad tree. Okay, so now we say here when we push this is actually before we push that, we're going to say if the tree length is equal to the count to split minus 1. So it's at 4. So the next one we insert will force it to split. So at 5. Right? So we're going to do that. Else we do this. Okay? Now, what we're going to need to do is we're going to need to take the tree we're in, store the data in it temporarily, so we're going to call this var temp tree. This is going to be a array of quad tree node. It's going to equal the tree. And now we're going to need to set the tree back to a regular array. And now we need to create 4 new trees, quad trees. So I'm going to create a private inline function, and we're going to say create new tree, and we're going to tell it the x, int, y, int, width, int, height, int. And this will give us a quad tree. And so we're going to do var val quad tree equals new quad tree. And we're going to get the total area, which is going to be a var new area. And it's going to be a rectangle. It's a new rectangle. And it's going to be x, y, width, height. Okay. And we're going to pass it the new area and the count to split and the max depth. -1. So we have that, var retval, or return retval. So that'll get us that far. So now, here we're going to say tree push, create new tree. It's going to be the area dot width, actually area dot x, area dot y, area dot width, and area dot height. And so I'm just going to a couple of variables here, half width. And we're going to do a int, and this is going to be math dot probably round, and this is going to be area dot width and half height, area height, half width, half height. Okay, and now we're going to need to add to the x the half width. Here I'm going to need to add the half height. And here half width and half height. And we have some sort of issue with our x. Line 30. Float should be int. I disagree. Oh, this is why. Divided by times 0.5 times 0.5. Now we got a float. And 30. float should be int. I see. So what we need to do is we could divide this and put it here. We could just use floats, which is probably better. So we're just going to stick with using floats. That's better anyways. We want to solve for that. Now, what we'll need to do is, wow, we got tons of errors. So now we've got all kinds of stuff going on. Mostly because we're populating the tree here. So what we need to do is we need to be able to repopulate the tree and traverse it. So here is, once we've created all of our pieces, private inline function split tree. And so give us our to be void. And here that way. So now we split the tree. So that simplifies that. And now we need to go through and actually insert into the correct spot. So for leaf and temp tree, we're going to need to do an add to each of those. So we're going to say we need to find what tree to put it in. Actually, that's kind of hard to find, isn't it? I feel like, actually, no, that might be okay. So one thing I do want to do, so we could change this to a vector. We can force the size. I'll think about that soon. Actually, I'm going to do that now. So we have a type called a vector, and this will be a, oh no, we can't do that actually. That's a bummer. We can't make it a vector because we don't know what our depth is going to be. So that's a sad thing. So now, and the reason we use a vector is because we actually know our depth, or we know our max number of pieces on this level, but we don't know it at our depth level. So that's a sad thing. So what we're going to do is we're going to say, here we're going to say find tree, and we're going to pass it the leaf area. Private inline function find tree rectangle. So give us a quad tree. And what we're going to do is we need to traverse the tree. So for tree in tree, and that's, call it branch. And we're going to say if rectangle intersects with the branch area, return In fact, what we're going to do is we're going to say insert into trees. And this is going to be a void. And now I'm going to say branch, and this is going to be a cast branch as a quad tree. And we're going to add the area, which will be insert into trees, and this is going to be a quad tree node leaf. Cast. Now we say this is going to be our leaf area intersects with the branch area. Branch leaf dot area leaf data. Okay, and so that will work for that. So now insert into trees. That should do that. Now we need to be able to find a get nodes at point. And what we can do here is we have our tree, and for item in tree, just thinking through this, get items at point, and what actually we want to do is going to break some of this down so it's a little bit easier to test here. So now we're just dealing with this one test. This actually may pass. I didn't actually check that. So it does fail. What we want to do is line 161. So we do a quick little trace in here. And we're going to say, ooh, and actually one thing we need to do is we need to do this. And so now we can say trace splitting. So now we can see, make sure that it's actually splitting up. I can't believe how much it needs to build just to put in a couple changes. It's definitely a weird issue there. So here, it's not splitting. So trace tree length. See what's going on here. 1, 2, 3, 4. So this loop is not correct. And so now we should get the splitting of the tree. Alright, so it looks like there is some sort of so we split the tree, create a new tree. Let's do this. This is unbelievable how much needs to be built. Okay, so that part succeeded. This is our quad tree test. There's a 10 seconds not being tested right now. But so now we need to be able to validate this here. So we're going to say in fact, this is going to be kind of weird because it kind of inserts and then inserts again. So we're going to do maybe like I times 10. Oops. But that's kind of not that great just because the this is an actual case. So what we need to do is, it seems to be kind of a recursive problem here. So we split on this. And do we want to do that before we split? Let's stick with it. So this will break way down. I think I want to set the max depth to something that's not so depthy. So like 10. And we'll say and max depth is greater than 0. And did we create this correctly? So we create a new tree. That should do it. There we go. So that passed. So we do have a maximum depth that needs to be set. That does help. Okay, so now what we're going to need to do is they're likely all going to fall into this one of these trees. Problem is that it's a little bit hard to validate. So what we're going to do is we're going to cook this up a little bit better. Is here is we're going to have value 1 or 0, and this is going to go into this rectangle. 2, 3, 4, 5. And so that's going to go into that rectangle. Jeez. 4. So this one's going to go into the one with all the way to the right, so we'll make it over 400. So we do like 550. This is going to go into the lower quadrant to make that 400. And this is going to be bottom right. And now we're going to stick this in the same quadrant we're already at, so we'll just do 90. So this should still pass. It should still split. But now, first quadrant, that still passes. This is going to be a quad tree. And in here, we should be able to say this technically shouldn't have built. It should have been pissy about this. I'll say assert are equal to first quadrant tree length. What's the problem? 173. Just cast that. And so that passes. So we should dry this up real quick and say 2, 1, 1, 1. This would be, which I'm going to keep this. We'll call this leaf count. Tree node leaf count tree node, and so that should pass. Cast and we're running out of battery, so I'm going to close this up real soon. And my mouse is being ridiculous, so that ain't helping. And quad tree. And we'll have our first real splitting of the quad tree. There we go. It all validated. So that's fantastic. Alright, and then just that one test alone covers most of this logic anyway. So what we're going to do is close it off for the day because we're running out of battery, but one thing that we need to validate is this one should probably still pass. It better still pass. And this one should still pass. And this one should still pass. And this one should still pass. And this one will not pass. That one will not pass. So the rest won't pass. That's okay. we're already back up to 70%. Alright, so we're going to close it out for the day. Probably going to do a cast tomorrow morning on Saturday to finish this off. We're pretty close as far as what we need it for. Still a couple of cases that we need to cover, but we're on our way. So let's go back here, get status, and I've made some changes here. So I'm going to add test collections, get status, get add sources collections, status, get status, get commit, work in progress on quad tree. And I committed those other ones anyways. Darn it. So what we're going to do is we're going to go to get X. This will be easier to do it here. Live game. And we're going to amend. And we're going to take off the game world. Are you kidding me right now? Amend. Input source listener. We don't want that. That's wrong too. And I'm going to recommit. And now discard this stuff. Cool. All right. That's it for today. And happy coding. See you over the weekend likely. And have a good weekend. See you next week.